Good morning, everybody. This is a course on Introduction to Database Management Systems, and we will be covering basics of this course in this class during the current period through which we go through this class. And today is the introduction. That is, we will just give you a basic idea of what a database is about, what it is supposed to do, and why is it like that. Now, DBMS is Database Management Systems. Now, a database is a collection of interrelated data. Okay, the first thing which a database management system has is, in a database management system, you have got two major components. The first is a collection of interrelated data. Which is called the database. And second component, or a second major component of this database, is a set of software packages or a set of software tools or programs in the most simple sense, which are able to do two things on the data, which first must access the data, sorry, there is a spelling mistake, which must access the data, and the other thing that it can do is process the data. This data which resides in the database. Now, this part of the database is often called the query and update mechanism. So, in a database, we have got two components. In a database management system, we have got a database which is a collection of the data, and second is a set of software programs or tools or programs which operate on the data. Now, it is important to understand that where this database management systems, how did this whole thing come up? Database management systems is nothing new. It has evolved over a long time because of the need for large scale software development. For example, a number of places require software to be developed and data to be stored so that multiple users with multiple requirements can access that data, can use that data, and can process that data. Several examples of such applications will be important for us to study. I will just give you one or two examples of such information systems which require a database. Consider a bank. Now, in a bank, you have got several accounts, you have got several deposits, you have got lockers, you have got check clearing, you have got checkbook handling, you have got several things like giving out of what do you have, things like demand drafts and many other things. Now, a bank itself requires to store a lot of information, and this data regarding accounts, what is there in an account, who are the users, who have got joint accounts, who have got lockers, who have taken a deposit and a loan, who has cashed which check, this information is to be stored in that bank information system. And this is to be used by several types of users. The bank manager may want to do certain things, a user may want to do certain things, at the teller certain information is updated, and therefore many such types of people access the data. Some access only to retrieve information, others access to process the data, to change the data. Okay, this is one example which is a classical example. Second very interesting example is a library information system. And all of you know that there are books, there are borrowers, there are people who have borrowed several types of books, there are people who have donated books, there are sellers who have supplied the books have been purchased through a certain process, there are people who issue the books. All right. So all this information is there in the library, and many types of processing is done on this information, and these processings differ. New things may be done at different points of time. A third classical example which all of you are aware of because it is available in India is the railway reservation system. I mentioned railway, it is there in airline reservation system also, but since most of us are conversant with this railway reservation system, we will see that you have got train information, you have got station information, you have got fare information, you have got booking information, you have got cancelling, and so many things, tickets, concessions, warrants, military warrants, so many other things are there. And you can imagine the number of people using it, the number of types of people using it, and in all three of them, and especially you will be more interested and you will be very much clear about the idea of railway reservation system, is that more than one user are simultaneously using that same data. More than one user is simultaneously accessing. Accessing is fine, updating that same data. Same thing can occur in a library, and this same thing can occur even in a bank. When the bank data is computerized all over the country and you want to get a clearing of your check here on the computer, which is going to be clearing a check which is there in, say, Calcutta, and maybe there is a facility to check your signature directly. Even automatic teller machines and other things which will come up very soon will also require this type of thing. So what we have is a set of data and a set of processes, but this data must be designed and organized in such a way that it is useful for the current application and it is useful for applications in the future. That is, it will serve multiple applications and it will serve for applications which may occur later in time, applications which may not be immediately occurring. So we must remember at least these, any office information system also requires a database, but let us keep in mind at least these three examples because they will come again and again. The difficulties related to solving the database or information system problem of these three examples will be coming again and again to us in this whole course, and we will continuously come back to these examples and see how we should design our database. But before going into the database management systems, we must have a quick look at what happened. Before the evolution of a database in the early 60s or 70s, these problems were still solved. How were they solved? They were solved by what are called early information systems. Classically, the method of solution of these early information systems was direct use of the operating system. Now, the operating system gives you access to files. All right. So the early operating system, early information systems were like this. You had a set of application programs, many programs. Today, take the bank example. Somebody wrote a program for check clearing, somebody wrote a program for account crediting, somebody wrote for debiting, somebody wrote another program for interests. Okay, somebody wrote another program for fixed deposit interests, taking care of all the fixed deposits. So these programs were written over a period of time and they accessed the file system directly. That is, the file system which is usually available in the computer operating system provides you a file system, every operating system, and this file system directly accesses what is called the disk, where all the data is stored. So you had this disk, and you had a large number of application programs, and these application programs were written to directly access the file system over a period of time. And a lot of problems cropped up with such early information systems. And we will see what these problems are, and we will try to see how database management systems are trying to resolve these problems. The first and most dangerous problem of such early information systems is the disorganized development. Since data was written, used and updated by various users at various points of time, nobody really knew what the other person had done. Even if documentation is there and standards of documentation were not well developed, even then it is not possible to write down the nitty-gritty of each and every program, and the software development does not allow you so much time to go through each and every program and find out what they have done. So first thing that happened was, whenever people wanted to use data, they really did not know which data was there, which data was not there. So they started replicating data. Data of the same type was there in different formats. Different data were there in different files in different formats. Today I wrote some program. I went and found that I required some information regarding pin codes of related to Kharagpur, so I wrote a program for pin codes for Kharagpur. Somebody went and wrote pin codes to find out addresses of all people who are living in Calcutta. Somebody went and wrote another program to find out all addresses of all people who are living in a place called X, where X is a parameter. So people started writing out various types of programs over time, and the problems which came up were data isolation and data redundancy. The relationship between the data became unknown, lost, and data became replicated in different formats. This is the core reason related to disorganized development. And it is not that if there was organization in the development it would have been done. It is an inherent problem because there was no conceptual build-up of what information I want. There was no formalization of what sort of information I really want. And this data isolation was and data redundancy were two major problems which cropped up here. Now these two led to several subsidiary problems, one after another. I will give you the next problem which cropped up was due to data redundancy. In inconsistency. When data becomes redundant, that means there is multiple copies of the same data at multiple places, and people do not know, all of them do not know which data is where. Now what happens here? Suppose your address is there in 5 places, and say in the unit trust you have given, and they have by mistake they have kept your data in 5 places. The same data is there in 5 places because one programmer wanted to find out how much dividend is to be given to you, and he copied the data and kept it there. The dividend program uses that data, the bonus program uses another data. Therefore, data is there in 5 or 6 different places, and because it is there in 5 or 6 different places, one program which updates on that data may make it inconsistent. One program, suppose one program changes the data, okay, changes your address. Now your address is there in 5 places. So how will your this affect your address? Your dividend program will calculate your dividend from your information and send your dividend to some address, and your address may have been changed there, but the place where your bonus certificate is to be issued, there the address may not have been changed. Because of this replication of data, the data becomes inconsistent. That is, there is the same data is there in 5 or 6 different places and is there in an inconsistent fashion. Inconsistency is a very dangerous concept. So you can imagine this is your address, you can imagine your bank balance is 5 places, your bank balance is there, and there are 5 different bank balances there, one for the deposit account and one for the interest account. Interest is coming and updating somewhere, your deposit is coming and updating somewhere, and so you can well imagine what problems inconsistency causes, and this problem cannot be allowed. And this problem came up again and again in the development of early information systems. The third problem is a modern problem. This problem came up because computers became better. Due to, the next problem which I will write down is a problem related to concurrency. Concurrency means that 5 or 6 people are updating that same piece of information at the same point of time, logically or physically at the same point of time. Now that comes due to time sharing. I hope you understand what is time sharing. In time sharing, even if there is one processor, different logical processors or users are there who are going to use that processor in slots of time. So everybody gets some unit of time, and that for that unit of time that person's job runs, then the job is suspended, and then the next job is picked up. This is a standard process which occurs in time shared operating system, and it is occurring in database problems as we discussed railway reservation system. You can see it, any reservation system, library information system, and so many other things. Now the question is, what problems does concurrency bring about? The problem of concurrency is that of updation of shared data. See, if data is not shared between 2 concurrent programs, they are not going to harm each of them in any way. But if data is shared between 2 concurrent programs, then there is going to be a lot of problems. I will give you an example. The example is like this. So suppose you are doing railway reservation, okay, and in railway reservation there are 2 people trying to reserve tickets on the same train on the same day. Now the program which writes this reservation is same for both. Maybe there are 2 copies of the same program, but the data is shared in the sense that the reservation table or there will be a file which stores the reservation. Let us take it for the point of time that there is a file which stores the seat number and the person who has reserved that seat, that is the PNR number or the ticket number. So this is the reservation table. Okay. This reservation table is shared between people who are trying to book tickets from different counters from different parts of the country at the same point of time. So there are two commands, one to book and another to book a ticket. Now what is the problem of concurrency? Suppose this booking program is like this. It first checks if seat is available. To do that, it goes into the reservation table and checks a piece of data which says total number of seats booked, and it compares that with another piece of data which says the total number of seats which are there in this particular table. Second, if it passes through this test that seats are available, then it goes down and writes into a particular seat position down the ticket number for that particular seat. So for a particular seat it writes down that ticket number, and the third thing it does is checks if seat is available, it increments the total seats counter, total booked seats. So it increments the total number of seats which are booked. Now these three problems cannot be done in one machine cycle. It takes a sequence of instructions, a sequence of file accesses, and it takes a considerable amount of time considering the time that is spent in running problems on a computer. Now this is where the problem comes up. I'll give you an example. Two people have concurrently accessed this. One person checks this and finds seats is available. At a particular point of time, he checks that seat is available, and he goes and writes down his on the seat number, say 21. He writes down his own ticket number. Now, at this point of time, another person also accesses this database. How can this person access this database? If there are two computers working parallelly and this database is there shared in a third place, then both of them can access simultaneously. If there is one computer and both of them are working on that in the time shared mode, then the time slot of this person may be over and the time slot of another person may have come. So this program may be suspended at this stage. So P2 comes up. So this was P1 and it is suspended at this point of time, and then P2 comes. P2 comes and checks. Suppose, I'll give you a simple argument, suppose there is only one seat available. P2 comes and checks and sees what seat is there. So P2 checks seat is available and writes his ticket number, and his time is such that in that whole period of time he writes his ticket number, increments the total number of seats to be booked and goes away. So P2 does this, does this, does this and takes a ticket. So P2 goes away with a ticket. So P2 gets the ticket on seat 25, say. After some time P1 is invoked, the process P1 is invoked. in time shared mode. In parallel mode also, you can look at it in the same way. And then what P1 does? P1 is already entered this place, and P1 also overrides on that place or gets the same ticket, increments this counter, makes this counter inconsistent to more than one, more than the total. If the number of seats is now booked, it may make it more than total, it may not make it more than total, but it may get a ticket with the same seat number. P1. P1 may get it with the same seat number, and you've got two tickets with the same seat number. Concurrent access is allowed always to make the program more and more efficient, because if you made railway reservation system sequential, you can well imagine you will never get your ticket in the whole day. Nowadays also it is difficult to get a ticket anyway. So to make concurrent access useful, you have to prevent the problem of inconsistency which may arise due to sharing of data. And this is a standard problem of operating systems, but in database the problem is more because the time to update is required is more. And we will see that early information systems did not have any inherent mechanism to tackle this particular problem. Operating system provides you facilities to tackle this problem on the memory, because operating system does all the sharing on the memory. But database, for database systems, this sharing has to be done in the secondary storage or on the disk. So that is another major problem. A fourth major problem which came up was security. The problem of security. The problem of security is like this. The problem of you have designed the railway reservation system and you have got the whole information of all the reservation system. So all the procedures are there, all the functions are there. Will you allow a person who is booking a ticket at the counter, who does that ticket booking for you, will you allow him to change the ticket number of even booked tickets? You will not allow. Then everything can happen. If everybody can do everything at every place from every terminal, then you are going to land up in a big soup. In a bank, the teller person need not know what you have kept in your locker, what is your locker number. So the aspect of security is that since there will be many people who will be using the database, each people should be provided access to only what is required, not to the whole database. And this must be done in an integrated and a consistent fashion. This cannot be done in a disorganized way. Tomorrow I will try to give security to 5 people. If 5 people write the program at 5 different points of times in just writing some application program, then you just may not know who will really get into the system. You cannot even have an integrated method of blocking this process. So this is an aspect which has to be seen very carefully. And there is another concept called integrity constraints or constraints. What are constraints? When you design your bank information system, it is always known that a checking account must not have a balance less than something. That something may be defined again and again. Now when you are doing an updation, that is when you are withdrawing money, that check should be automatic there. Now this withdrawing of money may come due to various reasons, and this check should be automatically there. Now the system will specify various types of constraints. One of the constraints may be there cannot be an account number in a branch which does not exist. Suppose a branch is closed down. You must check that all the account numbers which were related to that branch are not there in the database. Because tomorrow, so if the branch account information is somewhere, All the branch information is somewhere. Somebody closes down a branch by one program written in Calcutta, and the information regarding the accounts is stored in Delhi, and nobody knows what is the relationship between them, then this person will be withdrawing a lot of money and getting an account on a fictitious bank. So all these are constraints which have to be specified when you design the database. And this early information systems found very difficult to tackle. So the organization of the database slightly differs from the organization of the early information system, and that is what we will see now. In the early information system, we had an application program which was directly accessing the file, and that was accessing the disk. The database system is a layer in between these two, which really tries to organize the data, have a comprehensive view of the data, have all the types of problems removed at this stage, so that interaction with the operating system and the application program is now smoother. So we come to the role of a database. Schematically, a database program has got a set of application programs. These are application programs. These application programs do not interact directly with the file system. They interact with the database management system. The database management system in turn accesses the operating system, and one of the main aspects of the operating system which it will require to access is the file accessing software. This is the file accessing software which is available, which may have to be written by the database programmer in many ways. Some file accessing, file handling aspects may have to be written. That is, the whole of the file system may not be available, and database will be concerned with a lot of file system. So file systems will form even part of the database, and the end at the disk is the actual data which is stored in the disk, and we call that the database. So we have got the application programs interacting with a piece of software which can define, organize and utilize that data. We will see the inside of this a little later. This will make use of file accesses, and these files will be stored as data in the secondary storage, and that will be the database. So this is the very coarse view of what a database management system looks like. Another way of looking at the overall organization of a database management system is from the point of view of the types of users and the types of things that are done. One, so we can also call it the levels of a database. A database can be broken up into several abstract levels. This is also called data abstraction. Regarding this, we have got the first thing here is called the physical level. The physical level is what data is stored where, exactly how and where the data is stored in the disk. That is actually how it is stored in the disk. What are the files, what are the fields of the files, what are the types of the files, and this is the information which is, that is one view you can have at the last level, at the last implementation level, how a database looks like. It will be a set of files and these files and a set of programs, a set of files and a set of programs. Some will be data files, some will be program files, as is there in common at every point of time. This was what was there in the early information system. It was a set of files and a set of programs. But this is what is the lowest level of the database. Above this is the organization and the conceptual database. That is, what is the overall organization of the database. It is called the conceptual level. The conceptual level is the overall organization of the database. That is, how the database is organized in an overall fashion. What are the types of data? What is the logical interrelationships between the data? What are the fields of the data? And for a railway reservation system, it will be how the whole database is organized. Train information, fare information, station information. What is the information? How is it organized? How are they related to each other? There must be a basic inherent underlying symmetry, an integration mechanism, and a theory behind all these things. So that is the conceptual level. This is the implementation level. Finally, after implementation, what it looks like. This is at the design level what is looking. And there is an intermediate part which is called the view level. The view level is what the database, the conceptual aspect of the database as it looks to various types of users. For example, you may be in a bank, you may be a manager, accounts manager. It will look something, some portion of the database is available to you, and that is what is your view of the database. You may be bank manager, you will have another view of the database. This is the view of the database designer, the person who designed the whole database. He knows what is there everywhere. This is the administrator, the designer. So this is the view of the database administrator. This is the view of the database users, application users. These are sophisticated users. And at the last level, you can have the users view. This is a different type of users. Normally you don't have this, but the difference between this and this is that this is terminal users, those who work only on menus. They can write no programs. These are menu driven, naive users. Who work only on certain types of menus. They cannot use any other thing other than menus. You can do programming at this level. Obviously, you can do a lot of programming at this level. You can do programming at this level, but this is that of a designer, and this is what will finally be generated. After this conceptual level, and all programs will finally generate to this. Another important point regarding database, see, database is like programming a large information system. It is a method of organizing, programming and defining a large information system. And in this particular situation, like in any programming language, you can define the types and then the variables. Okay, 5 variables may be of the same type. For example, you can define an integer, you can define a structure, and then you can define 5 things of the same structure. In database, you have got what is called a schema definition, which is the definition part. Okay, it is the definition part, and the second aspect is the instance, that is the variable type. That is, this is the definition, this is the structure, and an instance is that database which has got this structure with its own type of data. For example, all branch managers may have a particular type of a structure, but different branch managers will have different instances. They will have different instances of that same data. So you have got two types of things, a schema definition and an instance of a schema. This has to be remembered all the while. So we have got the concept of a schema and a concept of an instance. Now, next we shall come to what are the components of a database. Now, how do you define a database? How do you design a database? And how do you use a database? It was mentioned earlier that database consists of a set of interrelated data and a set of procedures. So you must have a mechanism for defining that data and a mechanism for defining that set of procedures. So the components of a database from a user's point of view, there are two major components. One is called a data definition language. Every database must have a data definition language, which is in short called DDL. This is how you define your whole database. What is the data definition of your whole database? What are the information? How are they related? What is the relationship? This is what you store. The second must be a set of functions or procedures which access and process, as we have seen. So for that you must have what is called a data manipulation language. Or a DML. So these are the two things which every designer must have, a data definition language and a data manipulation language. You will define the data in this language, and data will be and you will write your functions or procedures to manipulate the data in this language. Now this data definition language will be an abstract language, and what it should be, how we should be able to define the data is one aspect we shall have to see. Data manipulation language can be of various types. All right. Now this data manipulation language is a very core concept in a database. It may be procedural, or it may be non-procedural, or it may be a combination of them. A procedural one is like your normal programming language, where you have a step-by-step definition of what you want to do, and a non-procedural one, so you can have procedural, non-procedural, next. The basic job of a data manipulation language, the 4 or 5 simplest operations are retrieve, insert, delete, these are the operations, isn't it? These are just the operations that will go on. It will either retrieve some information, it will maybe insert a new information, delete or update. Now sometimes a portion of this data manipulation language is also called a query language. query language is a portion of the data manipulation language which really accesses and retrieves various kinds of information. And since retrieval of information, like in the library, you may want to know various things: who has issued what book, who has bought what book, which supplier has supplied what book, and all these things. Therefore, a query language is always there as a sub portion of a manipulation language. Right? So, a data manipulation language has got a sub portion which is a query language, and in a normal program where you do data manipulation, you can use parts of the query language. So, we will see what this query language is about. Now, once you have these two things, this will interact as we have seen. A database administrator will do the database definition and will write down the queries at this point. Somebody will do it here. Now, what is available inside is the next important point that we will have to see. So, the first is the database administrator, who will, one important user is the database administrator, who will do what? He will define the database. The database administrator will define the database, and this database administrator will define the DB scheme. So, inside in the database, once this database scheme is there, this must be converted and stored into the disk as a structure. For example, if you write down in a program, if you write down a type definition, and when you compile it, this structure is stored somewhere, this information. So, we have a DB compiler, database DDL compiler. So, there is a software which stores in the disk what is called a data dictionary. This is the name. That is, whatever database scheme is there, it compiles this and stores it in a structured form somewhere. Another a type of a user will write application programs. Now, these application programs will be written using the data manipulation language, and therefore, what you need is a DML compiler. Now, this DML compiler will convert it to object code. Any compiler of a program converts it to object code. So, this is application program object code. Now, this will have to interact with the file system. This object code will have to interact with the file system. Right. Now, this interaction with the file system is not done directly. So, this interaction with the file system, so consider this to be your disk, and through time you have, through these application programs, you have already got some data files in the disk. So, this is the disk, and the operating system may or usually will provide you with what is called a file manager. What does a file manager allow you? The file manager allows you access to data, and this data is accessed through, the files are accessed to read, write and all these operations which are provided by the operating system. Now, these will have to interact with the file manager and access the data. Now they must know which data to access. This data which has to be accessed will depend on the way the data is stored. The data is stored and defined. So this accessing of this whole data is controlled by what is called a So all application programs interact with the database manager. This database manager will do something, will be a set of programs which will be compiling, executing, editing, and whenever file access is required, it will access the files, but it requires to know the structure. It requires to know which file to access, what is the format of the file. All the details are available in the data dictionary. So data dictionary is stored from the DDL compiler. You have defined a database key, and from this all, what structure is your files, what are the format of your files, what are the fields of your files are stored in this data dictionary. This is the structure definition of your database, translated at the physical level. So this database manager will get this information and then know, I want, because this application program will say I want the balance of this person. So to know the balance of that person, that the balance is stored in a file called accounts, and this accounts file, the third field is balance, and the third field balance is a field of 10 characters, 10 places of decimal, okay, a numeric value. So that will be gathered from here. This gathering, the application program will just say balance from this database, the accounts data I want. So that will have to be converted to file system commands exactly, and that file system command translation is done by the database manager. Other than this, you can give what are called queries. These queries, as we have seen, are just certain retrieval commands, and these queries will have a query processor. We will slowly see what queries are, and application program may have embedded queries. So application program may require the query processor to process the queries, and this will interact directly with the database manager. This is what the core of the structure of a database looks like, and this is what is that internal mechanism which we were talking about. The role of a database manager is very significant, and we will quickly discuss that. The first is, as we have seen, interface with file manager. The second is integrity constraint enforcement. Whatever are the integrity constraints which are defined here will have to be checked. All backup and recovery are checked here. The concurrency control is checked here, and many other things which are problems of standard file systems are all controlled by this database manager. Concurrency control and all these things. So we will see what these problems are and how they are to be solved by the database manager at various points of time. So we will terminate this part today, and we will continue with an introduction tomorrow to see what are the slightly more detailed roles of these database management systems and what are the types of things that are done in a database.